In this lesson, we're comparing quadratic functions, and so we're going to be looking at quadratic functions in the form of equations, graphs, as well as charts. So let's go ahead and get started. Some prerequisite skills that you're going to need for this lesson are understanding vertex form of a quadratic function, converting quadratic expressions from standard to vertex form, factoring perfect square trinomials, and solving quadratics by factoring. If you're not quite sure about these prereq skills, I've linked the playlist at the end of this video, so if you need to go back and review those before doing this lesson, go ahead and do that. But if you think you're ready, go ahead and let's do the first problem. For example 1, it says Ruby and her friend Lila each toss a quarter off the Main Street Bridge in the St. Johns River. The functions for each are given below. Ruby's toss is here and hers is in the form of an equation, and Lila's toss is right here and hers is in the form of a chart. So we want to refer to these two algebraic functions in quadratic form to answer these questions. Question A, it says, what are the y-intercepts of each function? And so since Ruby's toss is in standard form, ax squared plus by plus bx plus c would be the y-intercept, which is the initial value. And Lila's toss is right here. And the y-intercept here is 112 because where your input is 0, your output is 112. So basically where x is 0, whatever your value for y would be your y-intercept. So the y-intercept for both is 112. What does each y-intercept represent in the context of this problem? And think about y-intercept. It is the initial value. So this represents the height or the initial value from which the girls toss the coin. Let's look at part B. It says, how do the y-intercepts of the two functions compare? What do you think? Well, as we can see, they're standing on the same bridge. So both girls are standing, they're on the same bridge because both girls are standing on the same bridge. So they, of course, start at that same initial point there. For the C portion of this problem, it says what quarter or whose quarter went higher when thrown in the St. Johns River. And so if we look at Lila's toss right here, her highest point was at 116. And so we can simply look at the chart and say that her highest point was at 116. But for Ruby, we have to actually find the vertex. And so this is the vertex for Lila, but we have to find the vertex for Ruby. And what I'm actually going to do is rewrite this in vertex form. And I do this by completing the square. So I'm just going to rewrite this expression. I'm going to set it equal to 0. And I'm going to look at solve it as if I'm completing the square, but I'm really just rewriting it in vertex form. And so when you're completing the square, you move C over to the other side. So since that's a positive 112, I'm subtracting 112. I'm left with negative 16t squared plus 32t is equal to negative 112. Now I want to factor out the greatest common factor between these two. So the greatest common factor here is actually negative 16. And I only want to take out the number because on the inside, I want to actually complete the square. So I'm leaving parentheses open here. So I'm going to bring down, so negative 16t squared divided by 16 is just t squared. 32t divided by negative 16 is negative 2t. And so I want to complete the square. So I'm taking half of b and dividing half of b and raising that to the second power. In this case, b, which is the number with the exponent of, with the variable with the exponent of 1. So in this case, b is negative 2. So I'm going to take half of negative 2. So I'm writing at the top now. So negative 2 divided by 2 is 1, or negative 1. And I'm going to raise that to the second power, and I get 1. So I'm using this formula, b over 2 squared. So completing the square, half of 2, and taking the result and raising it to the 1/2, and raising it to the second power. So I'm adding 1 right here. And I want to add the equivalent on the other side since this 1 is really being multiplied by the negative 16. I have to add that equivalent. So negative 1 times 16 is negative 16. Now I'm going to factor what's inside the parentheses. That would be t minus 1 squared. I simply take the square root of the first term and the third term. And if you think about it, two factors of 1 that have a sum of negative 2 are negative 1 and negative 1. So this is actually a perfect square trinomial right here. So I use that method, perfect square trinomial. All right, and so on the other side, negative 112 minus 116 is negative 128. And I want to move that 128 over. And then I will have my problem in vertex form. And vertex form is here. That's what I'm looking for. All right. So finally, that would be negative 16 times t minus 1 squared. And if I move that, I added that 128 plus 128. I don't need the equal 0. So this is my problem here in vertex form. So my vertex is h and k. So if we look here, hk, so h is next to this minus sign. If that were a plus, it would be the opposite. So my h is 1 and my k is 128. So the vertex for Ruby was 128. So that was her highest point. So whose ball was thrown the highest? It was Ruby. Ruby's quarter reached 128 feet, while Lila's quarter only reached 116 feet. This example here says, Ferdinand is playing golf with his brother Ricardo. Ferdinand hits a shot off the tee box that is modeled by the function ft, given in the graph to the right. And so this would be Ferdinand, where ft is the height of the ball in feet, and t is the time in seconds in the air. His brother Ricardo hits his ball off the same tee box, but the trajectory of the golf ball is modeled by the function rt below. So this is Ricardo, where rt is the r of t is the height of the ball in feet, and t is the time in seconds in the air. All right, so part A. So we have a part B. I'm going to do part A. It says whose ball goes the highest. And so we actually have to find the vertex. And so if we look at Ricardo, we can look at the graph. His highest point here is at 100. So the height for Ferdinand is 100. So now we have to actually find Ricardo's height. And so we have to rewrite this problem in vertex form. So I have negative 16t squared plus 64t. And what I want to do, I want to factor out this negative 16. So greatest common factor. But I don't factor out the variable. So I factor out, so just rewriting this in vertex form. And I'm left with t squared. Negative 16t squared divided by negative 16 is just t squared. 64t divided by negative 16 is negative 4. So when I complete the square, it will be 0 on the other side. And so, forgot the 4t. I want to take half of b and divide by 2. So b in this case would be negative 4. So half of 4, so I'm dividing by 2, and I'm raising that to the second power. Half of 4 is negative 2, and negative 2 to the second power is 4. So I'm adding 4 to both sides, but I have to add the equivalent on the other side. So since this 4 right here is really being multiplied by negative 16, I have to multiply the 4 times negative 16 and add that on the other side. So 4 times negative 16 is negative 64. And I'm going to continue to write this in vertex form by factoring. So that would be t minus 2 squared equals negative 64. I simply took the square root of the 4 and the square root of t squared. You would just take half the exponent. And my exponent here is 2. So again, this is a perfect square trinomial. And so to write it in vertex form, I just want to move this 64 back over because I want it to be set equal to 0. So it's plus 64. So now my vertex is written in this form. My vertex is h and k. So h is 2 because in the formula it is minus. So it's going to be an original positive 2. So the vertex here is 2, 64. So this is my k. So his y value, which would be the highest point, is 64. So whose ball goes the highest? That would be Ferdinand. Ferdinand's ball went the highest because his went up to 100 feet, whereas Ricardo only went up to 64 feet. For part B, it says whose golf ball was in the air the longest. And so we want to find the zeros or the domain for these two functions. So if we look at Ferdinand right here, his ball went up right here and then it stopped at 5 seconds. And so Ferdinand's ball was in the air for 5 seconds. All right, that's a 5. And we want to find the domain for Ricardo. So we can do that by finding the zeros, because if we look at the chart here, these are the zeros. And so zeros are where the graph cross the x-axis. And so right here, I want to find it because I don't have a graph for Ricardo. So I'm going to find the zeros by factoring. So rewriting this expression for Ricardo. To factor, I have to set it equal to 0. And I'm just going to solve by factoring. So the greatest common factor here is negative 16t. And if I divide everything by negative 16t, so that would be t minus 4. And then I want to set these two expressions equal to 0. So of course, if I divide by negative 16, one of my zeros is 0. I don't need that. I need my highest 0. So t minus 4 equals 0. Adding 4. All right, so the domain was from 0 to 4, so Ricardo's ball stayed in the air of 4 seconds. So whose ball stayed in the air the longest? That would be Fernando had the golf ball in the air the longest at 5 seconds. I would like for you to try this problem on your own. Go ahead and pause the video and try this problem on your own. So the question asks which bottle rocket reached a greater height. And so GT reached a greater height at 586. Hopefully you got it correct. Compared to H of T, which reached a maximum height of 400 feet. And for H of T, we had to rewrite it in vertex form. So vertex was 400. And so, of course, 586 is higher than 400. So hopefully you got this problem correct. I would like for you to try part B on your own. Go ahead and pause the video and try this problem on your own. For part B, it says which bottle rocket fell to the ground first. Hopefully you got it correct. It was H of T. Right here, let me put because it fell after 10 seconds, we had to find the zeros. Here for GT, it fell between 12 and 13 seconds. So it was at a negative right here. So 12 to 13 seconds and 10 seconds. So H of T hit the ground first. So hopefully you got it correct. We reached the end of our lesson. I want to thank you for learning with me. Some related videos are below. If you haven't, please like, comment, share, and subscribe. And once again, I want to thank you for learning with me.